I'd like to introduce Mr. Anil. Mr. Anil is an electrical engineer and current secretary at AAR. He previously served as past president of Association of Ammonia Refrigeration. As the director of DAG-TECH-SERVICES in Pune, he brings over 3 decades of industry expertise, having worked with multinationals such as Kirloskar and Allana. His diverse experience spans food processing, cold storages, meat and fish processing, fruit and beverages, dairy plants, and pharmaceuticals. Mr. Gulanikar has presented technical papers at international conferences, including at IIR and IIAR conferences at USA. As a member of AAR, ASHRAE, and ISHRAE, he is a regular speaker and trainer in Indian refrigeration industry forums and has contributed to Asia Cold Chain Show in Bangkok. Today, Mr. Anil will talk on ammonia as environment-friendly, sustainable, energy-efficient refrigerant. So without further delay, let's welcome Mr. Anil.
So since 1875, ammonia is used as a refrigerant, and it is continuing throughout since 1875. So that's what the study shows. There are list of other refrigerants which you can see they are coming, they are stopped in between, then they continued. So it is, if you see this, ammonia is the refrigerant which is used continuously, and it is going to be there forever. There won't be any stoppage, or there won't be any discontinuation, there won't be any phase down for this refrigerant as this being a natural refrigerant. If you see these slides, there are CFCs, then we have HCFCs, we have high GWP refrigerant. Then there is a further development on low GWP HFCs, and world is now moving towards green cooling, that is natural refrigerant. And what we are looking at is not only use of natural refrigerant, but which is having an energy efficiency also. So we are looking for both. One is the refrigerant has to be natural because it helps environment, and the energy efficiency. So what refrigerant actually we should use? Let's forget whether it is ammonia, whether it is any kind of refrigerant. When we want to construct a refrigeration plant, here I'm talking about industrial refrigeration system, not the commercial or HVAC related thing. I'm talking about industrial refrigeration system. What I mean by industrial refrigeration system is refrigeration system used for energy efficient, food processing, beverage processing, meat processing, any kind of food application, cold storages. So these refrigeration system, they are called as industrial refrigeration system, where the refrigeration system is used for a processing industry or the cold storage industry. So those application I am talking about the use of natural refrigerant. So what refrigerant should be? The refrigerant should have a low cost, naturally, easy availability, easy to use, energy efficient. You can see from all these things that these are the basic criteria which refrigerant should have when we use it for a industrial application. So which refrigerant fulfills this the most is of course the ammonia, because if you see the cost of ammonia in India is, the basic cost comes to 75 to 80 rupees a kilo. So which is the cheapest refrigerant available, and the cost is not going to increase, or not much difference will be in the cost, because this refrigerant is produced in India and it is a byproduct of a fertilizer industry. So as long as the fertilizer industry is in India, this refrigerant is going to be there, and there is no question of we have to import the refrigerant. So low cost is there, easy availability is there, easy to use is there, energy efficiency. We will see in the presentation how best is ammonia refrigerant as far as this system is concerned. So what are the major requirements of ammonia? Ammonia has to be pure, that is 99.95% pure, and we in India, we get this refrigerant as pure as we want if we insist for it. And various characteristics of ammonia is classified in ASHRAE. So ASHRAE classified ammonia as B2 category. B2 is the it is related with toxicity. A2 category, B2L category. So it is related with, it is less flammable, but it doesn't talk about toxicity. If you see this category, A3, B3, and then if you see ammonia, ammonia is in B2L category, that is lower flammability category. Ammonia is not flammable. If it is at, it gets flammable only when it crosses around 750 degrees Celsius or 650 degrees Celsius temperature. So it is not, so it is lower flammability is what B2L ASHRAE classifies. That helps us to use this refrigerant very safely for any kind of refrigeration system. Basic formula of ammonia is NH3, that is, which is a very hard closed compound refrigerant. It doesn't break. Other refrigerants are blend, so it may change if the circumstances changes. So when it is closely blend, it is not a blend and it is a natural compound. The properties of ammonia remains unchanged even if you use it again and again and at a classified temperatures. Then we have two criteria: ozone depletion potential and the GWP, global warming potential. Nowadays, it is more importance is given to global warming potential. And if you see ammonia, ammonia is less than 1 about global warming potential, and ozone depletion potential is 0. As we know, HFCs and SCFCs, various options are coming up, but as they go lower on GWP, the flammability of refrigerant increases. That doesn't happen with ammonia. Along with ammonia, there are natural refrigerants where ozone depletion potential is 0, and the global warming potential is 3, 1 or around that, but ammonia is less than 1. That is what it is classified. Then there are various phase down schedule, and as far as India is concerned, I think 2040, 2050 is the phase down schedule decided by India, and we are also on the verge of signing of Montreal Protocol, Kigali Agreement. So we are in the process of what we wish we should do. Here I would like to stress upon is that we have been using ammonia as a refrigerant since 80-90 years in India. Most of the food processing plant uses ammonia, and ammonia gives them, we will come after the next slides. If you see this is the exposure limit. What does it mean? That how many minutes if you get exposure to ammonia in what ppm level? If you see this 30 ppm level at any 8 hours, it doesn't affect anything to anyone. So people can work with 30 ppm level for 8 hours till their retirement. Nothing will harm to their body. And for your information, at 25 ppm leak of ammonia, our nose is a good sensor. So if you move around and if you sense ammonia by your own nose, the level can be 25 to 30 ppm. And if we don't take care when we smell a leak, then who is to blame? It's not the refrigerant, but it is we have to blame. So there is a lot of fuss about ammonia, that there are a lot of misconception flown in the market related with ammonia. But we have a gas cylinder or we have a pipe gassed in our house, so that is highly inflammable. We get a lot of incidences of blasting of gas cylinders. But if we don't take protection for anyone, then that's going to happen. But if there are blasts in the cylinders, or there is a petrol in the car which is also highly flammable, but do we say that don't use this? No. we are continuing it. Why we are continuing it? Because it is giving us benefit. And if the protection is taken, lot of the care is taken, and the system is designed by a proper design engineer as per the standards, then there are no incidences or nothing will happen related with ammonia refrigerant. No accident can happen if we take care of the system design itself. So when we design a system, when we conceptualize the system, if we follow all the standards and procedure, there should not be any problem till the life of plant of ammonia refrigeration system. Internationally, the life of ammonia refrigeration system considered is 15 years. So I have been in this line for more than 37 years, and whatever systems I have designed, there was not a single accident, because the systems were designed, conceptualized, operate, maintained as per the requirement. If we do this, and that is always there for any vehicle, if you say we have to carry out maintenance, if you don't do that, there are breakdowns, there are accidents. We have to take care when we operate, there have to take care when we design, and we have to take care when we do the maintenance. If we follow these three strategies, ammonia, nothing will happen to ammonia. What we have seen is, normally if something happens to ammonia plant, within a second every whole world comes to know that there are problems with ammonia system at this particular place, at this particular country. But nobody tells about what happens when HCFC refrigerant leaks. So what I have heard in international forum, that more people die because of HCFC or CFC refrigerant leak, but not than what happens with ammonia. So because there is no measurement level, there is no sensors there, because you can't smell it, so there are no sensors. But in ammonia, lot of sensors are there. If we take care, we know that there is a leak. So there are all pros and cons, but lot of myths are floating around related with this refrigerant. So if we see, even at a ppm level of 220, there is no cause of disability, nothing will happen. And only when it crosses 1000 ppm level, then the serious matter can happen. But why it should go to that level when we have all precautionary measure available? So this is again tabulated, and if you see 100 up to 100, we don't have anything major problems with any human being. So if you see this chart which is given in ASHRAE, the energy efficiency at -6.7 and 30-degree condensing, this is only a case, but it is true for any given parameters. The COP is 4.94, 4.96, which is higher than any other refrigerant. So there are people who says that any combination makes, this particular combination is energy efficient, this is more energy efficient, but as far as the facts and figures are there, there is no other refrigerant which is efficient, energy efficient than ammonia. If you see, the advantage of going for ammonia is, I have given a comparison of line sizing. Since the molecular weight of ammonia and enthalpy is favoring us, for the same capacity, the sizes, pipe sizes of ammonia are lesser than R404A. Then these are the specific characteristics, that low specific volume, high latent heat, low viscosity, high thermal conductivity, all this contributes to energy efficiency. Then I was fortunate enough to participate as a team member for the standard which is developed by India. And Association of Ammonia Refrigeration developed a standard for ammonia refrigeration system design and installation practices. As India was about to sign the agreement, world agreement, there was a clause that India should have their own standard for ammonia refrigeration system, which was not there. So fortunately, we handed over the copy of what we printed as proposed to be a standard to Environmental Ministry, and then they forwarded this to Bureau of Indian Standard, and now this is published as an Indian standard. So I was closely associated in all this process, being a part of Association of Ammonia Refrigeration. And if you see this standard is now published, and if in India, if we follow these standards, then definitely the ammonia plant will be more energy efficient, sustainable, environmental friendly, as well as the intensity of accidents will be so less, or intensity will be so less that there won't be any harm to the human being. Then there are various other standards which are followed worldwide. Is IS 17773, that is the Indian standard. Then EN 378 is the standard. ASHRAE 15 is the standard. There may be other standards available, but we in India now we are supposed to follow IS 17773 for system designing. I have some comparison for the project which I executed with R134A against ammonia. You see point number 6, the COP everywhere is better in case of ammonia. This is a case with minus 10,000 metric ton of capacity of a frozen cold storage as compared to 404A. If you see for air cooled application, the power consumption for ammonia is 60% lower in case of Freon air cooled, and Freon 2 stage is 37.6%. So these are the facts and figures taken from the project which is got converted from Freon to ammonia. So these are not hypothetical theoretical cases, these are the actually proven cases at site. Then ammonia is used as a refrigerant nowadays, or rather from year 2000, in various public places like airports. There are international airports are now getting used with ammonia chillers, water chillers, and it is slowly there are then most of the innovations since 1999 till now, the use of ammonia in large air conditioning complexes like airport and other things are going on, and it is taking place, and a lot of R&D is going on for this. This is again a comparison of case study for the cold storage of -25, which all proves that ammonia is a basic, more energy efficient refrigerant. As compared to CO2 also, CO2 134A, entire CO2 ammonia, instead of that it is 100% ammonia, it is always gives better energy efficiency. I am talking about Indian conditions where the ambient temperatures are high. In case of CO2, 33 degrees is the critical temperature, and after that we don't know, it has to be a very special system. So we don't, which is the cost so far in India of CO2 system is very high. So best refrigerant for Indian environment as on today is ammonia, and it is going to be there. So if you see this, from this conclusion is the best natural, sustainable, energy efficient refrigerant is ammonia. Thank you.
Thank you, Mr. Gulanikar, for talking about ammonia as environment friendly, sustainable and energy efficient refrigerant.